And I want to ask a quick question. Um, Algorithmic way to learn music. Okay, so the very first question I want to ask is, well, first of all, actually, first of all, Sophie's just asked a question about worksheet 3. So first of all, I think I owe a little bit of an apology. You might have noticed on the Moodle page, I thank Spencer for asking me the question, and then it suddenly dawned on me that there was a little bit of a potential overcomplication somewhere. So yeah, and Max, actually, you can learn to play piano without theory. Absolutely. When it initially came out. Okay, so if you've done worksheet 3 and you ended up thinking, okay, there are arrays, let's stick some arrays in, that's fine. All I want to say is you don't have to, because these worksheets were built to let you build your skills. And the idea was for the worksheets that you've been doing this week, and with the breakout sheets and the rest of it, that it was just to build up more practice. And it's my fault entirely. I did not make that clear. So those of you who haven't done them yet, if you've done arrays with them, and you've found some way to use arrays, fine. No one's going to freak out about it, certainly not mark you down. But my point to anyone is that you didn't really need them. It was for week 2 material, just loops and if statements to get these sheets, these week 3 sheets done. Okay, so that's my apology out of the way, that we learned arrays and then saw the worksheet, no arrays. Yeah, so Matthew, that's exactly why I'm apologizing. It dawned on me only later that this week had been split. Basically, the concepts for week 3 will come into be used properly in week 5. And I'll show you the plan of action and why it links together in such a strange way. My idea, it worked much easier last year for some reason. And then suddenly in lockdown, it dawned on me that I haven't made that split, or think. I sort of created a split apart. So these concepts, the idea is that if you haven't gone through these concepts, you'll find that when you get to week 5, it will bounce you back to them. So you practice and make sure you understand how arrays work. And then when we get to week 5, you'll see what's going on. So that's the first thing I want to say. And thank you for Spencer and for a couple of others who spotted the fact that there's a gap and I hadn't registered that, I hadn't clarified that at all. So those worksheets that you're getting marked don't need to have arrays. If you've struggled with it, yeah, exactly. It created a little bit of bafflement, and that's right. Kobe, that's absolutely right, yeah. So, yeah, that's cool, Declan. I like that, absolutely, yeah. So look, don't worry, because every one of the staff, I'll say to them, if the people have used arrays and done it in a slightly complicated, it's not your fault, it's me for not making that clear. And this week did slightly split, I remember now from last year. So what I did, okay, so let me just update you. What I did was I went back through weeks 4, 5, 6, and also the whole structure of how I'm doing it with you, given the fact we're in lockdown. Because after all the conversations I've had with people, I've made plenty of notes, and I have talked to people as we've gone along. And I've made notes about it, about what you're experiencing, what makes sense, what doesn't make sense. And so I thought, let's shift things around to make it work for lockdown. So I ask a very simple question. Who's feeling fatigue? A little bit of fatigue, if I can put it like that. A sort of slightly relentless, yeah, always fatigued. Exactly. Okay. That's the impression I have. And yeah, some subjects definitely. In general, yeah, perhaps in general, but the overwhelming, relentless nature that we just, every week we're throwing new stuff at you, and it kind of wears you down a little bit. Don't even with, okay, we won't talk about DSDs and databases here. Fatigue plus plus. Yes, that's actually probably a very good description. Have you forgotten the shape of the color of the sun? Okay. Yeah, Christina, it's ironic because I'm quite instinctive. I'd like to think I am. I'm not necessarily all the time. And what I've done when I sat down on Monday, there might be some wording issues. Some people are spotting your typo. I reworked the next 3 weeks, and I reworked how I'm going to link it together. Okay, so this is my aim. My aim is to try to give you a little bit of breathing space, but not stop you from doing stuff, right, in terms of Java. So the idea is in these next 3 weeks, so you can see my Moodle screen, I hope. You can all see that, yeah? No, motivation plus plus, I like that. Okay, so there's a very interesting experience for a sizable proportion of the student population. Exactly, that you're feeling a month behind, you're feeling like you're constantly catching up. I think these are the things when I've asked people how they're getting on, they feel like they're just about to catch up and then something new is introduced and then they feel they're falling behind again. So I want to try to remedy that, but I want to do it in a way that's actually useful. Okay, so if you can bear with me for 5 minutes, I'll try to give you my thinking process and how I've made some very minor tweaks and restructure. Okay, next week is essentially a very easy week in terms of coding, right? The exercises and the stuff that, yeah, I wanted to be July as well. So if you've already been working on creating your own, what do I call them, helper classes and static classes, and all of that kind of stuff, and you've started that, what you will find that what I did with week 4 is that I've gone through it more systematically, because I had a couple of conversations with students and some students said they wanted to avoid using them and see how they would code, but actually it's good, creates good quality programming when you use these types of mechanisms. And what we're talking about is you're trying to hide code mechanisms. So these videos basically will go over stuff that you, I hope, will find really straightforward. Okay, at least the 4a, which is the static class, it's a repeat in a systematic way of the benefit of creating, say, a console interaction type class. Okay. Then I also introduce a calculator class, which is an obvious and simple alternative in that second video. Very easy to code because some of you are already doing it. So when we come to 4b, in this hiding the static classes versus the object, that's the new concept. That's where I sneak in a new concept. And I do it by getting you to build something I hope is familiar and you've seen a bit of already, this static class, this helper function in a class and all that kind of stuff, right? And then convert it into an object and see how they both look and feel in terms of how you code with them. Obviously, and then I try to explain some of the concepts, why objects are so much more important. So there's a little bit more chat, a little less in terms of throwing constantly new concepts at you. The worksheet video, the worksheet for 4C for next week, I would hope you find reasonably light. You're just building a calculator, and this might look more complicated than it is. It does bring arrays in, but it's actually not adding essentially anything really dramatically new to the setup. The idea is that in that week, you kind of retread stuff we've been more or less covering. You're introduced to the concept of an object. You're building your first object, a simple calculator, right? And you can do it with the static classes and then convert it. Watch the videos through and you'll see that's a nice simple way of getting your head around what that means. So that next coming week is, I would hope, not a huge strain in terms of you having to grasp radically new concepts or something unfamiliar, because Java is quite exhausting, let's face it. The other reason that I'm approaching it like this, the typo on 4C, there a multi, let's have a look, let's have a quick look. Yeah, I thought I'd corrected it. There might be a typo. Let's have a quick look at that, Lucas. Hang on a second. What is it? 4C. There isn't a 4C. You've just been cheeky. Question 5. Can you create a second multiply method which has a single parameter of an array of doubles, and inside the method multiplies the values of the array, returning the result as a double? Which bit do you think have I done wrong? I thought that was certainly better than my first draft. Just tell me where you think the typo is or what's not clear. What's crucial about these questions, and this is really, really quite important. Lucas, please feel free to. I have no problem with them making corrections on the fly if there's silly typos left in and errors in there. The point of these excerpts, I think you may have changed it. I might have done. You might have seen an earlier version where a student contacted Peter and said, "Now this question seems really obscure." And then I read it and I thought, cool, it's really clumsily worded. If you do find that, please email me and I will correct it. You know, when you do things quite intensely and sort of binge work as I do, it does happen. Right, so the idea is this might look more complicated, but if you work through the material, it should, this is my aim, flow quite neatly. You mentioned in 3 that we may use helper functions in the same file. Is there a point in having a separate helper class if we have to include the functions in the worksheet? Right, that's a very good question, Christian. If you watch what I say about static classes, which is essentially how we gather together helper functions, what I did is I took the concepts that we've been discussing and that have been mixing around with all the various different concepts and ideas people have had, and I haven't tightened it up until this week. So in this week, I introduced you to the idea of having a static class which is responsible for one thing only, to get input from a console and output to a console. And by gathering them together in that logical way, that's a very good use that you can carry on using into your coursework. If you build it now, you can use it in your coursework. The rest of your stuff that you will build will probably be better off using objects, right? Including the calculator at some point. What I'm hoping is that in week 4, you'll find it reasonably straightforward to get the concept of an object. That's my aim. Then when you get it, I'm not sure if I did fully answer you may use helper in the same file. Yes. So in 3E, feel free to move it into a helper class of your own. 3E was the minimal threshold. I think I just read your question again, Christian, and realized what you've asked me. 3E was a minimal threshold. The minimal threshold was if you wanted to have a helper in the easiest possible way, you would put it in the same file. That's the easiest way to do it. Putting it in a separate file, linking it up with an import statement. As you watch one of the videos, I actually keep on botching it up, as I did last week, because it's just really annoying. You have to put the static word in, you have to specify the path differently, etc., etc. It's slightly trickier. So I've tried to give a minimal threshold. And I say may. For those who might not have used, there are some people who haven't used helper at all. And so the idea is that I want people to start writing good quality code, right? So this is my aim here. I want you to create good quality code, right? And what do I mean by that? I mean that it's easy to manage complexity, right? So you've got a program which you'll get in your coursework, and I'll come to how that fits together. You don't want to be writing all lines of code again and again and again. You want to have all of these different techniques that I'm talking about, so you can, if you know you want to interact with the interface. I intend using it, but most of the examples so far are being used of Python, Joe, it's encountered, it's supposed to be learning Java. Then, okay, that's an interesting perspective, but it isn't a Pythonify. Static classes are an actual phenomenon in Java. They go back to C. What they are is they're not objects, and they function differently, but they have a use. And certainly for this introductory course, if you watch, Charlotte, if you watch through these videos, it'll be interesting to see whether it makes more sense why I've introduced them and what value they do have. They do have a very limited use. But here's the thing about Python. Python itself is an object-oriented programming language. You can do everything in a proper object-oriented thing. Yeah, you're welcome to share your helper functions with each other, folks. Here's the thing about it. You are trying to develop scalable, right? There's some of the issues that we have when we write really important code. Scalable. Can your code deal with large scale systems? Well, static classes, and that's use of the word static, you'll see in the videos, it doesn't scale up. It has a limited use, but the use it has at an introductory level is quite useful for you. In fact, in my professional career, we created utility classes, which we just used to do certain calculations. It never held data, and they served a function. So they are there. They're part of the landscape of these environments. They do go back to C, not to Python. They predate Python in that respect. Yeah, it's more, I'm not sure if I do understand your question, your point. I understand the math section of that, but the others are already things that language supports. I think I need to understand your question a little bit more. But the point is, right? Oh, I see. I didn't look at Kobe's. Yeah, Kobe, what we've got to try to do is separate out the helper functions. Helper functions, the class of helper functions in a static class that you want to use, you should only use for console interaction, right? Now this sort of addresses what the point Charlotte's making. If you use it for everything else, then you're overusing it. Okay, you can have an add function, a multiply, and so on. But it has a limited use. Watch the videos, watch the material, and see if it links together in a clear way. Okay, what we have when we write it, you have two issues when you're new to it. When we talk about good quality code is readable, right? Scalable, and it has one really critical quality. And I'm going to take a phrase from one of the lecture notes for next week, just to give you a taste of it very quickly. When you code, you have a concept of what your code is trying to do. And ideally, if you create functions or wrapper functions on processes and mechanisms which have the name of what the concept is trying to do, right? To give you a really crude. Okay, I'm going to say, I'll come back to your questions in a second. Have a look at this one here. Right, this was one of the examples I used in the videos. I was talking about the same point, and I created one not called print. I said, if you've been consistent, the phrase output to console is a more accurate description of what this does. Okay, so what you're trying to understand when you write good quality code is that your code is readable from a concept point of view. That's what the code's trying to do. It's almost like pseudocode, right? Because you're naming functions which help you code. It scales up amazingly well. What most of you did this week, and I asked one of the students to send me some sample code, but I don't want to necessarily drag on with this, because this is all in next week's material, is that lots of you coded really well, but the most impressive examples were, interestingly enough, those who had used well-named wrapper functions. Now, at the moment, we're just talking about static stuff, but forget the word static. The critical element is a wrapper, a function which wraps some kind of mechanism, right? Might have a loop, it might have let's take the is prime example, right? That's a very, very good wrapper function. It takes a concept, you pass it the parameter, it gives you back a true or a false, but the mechanism of how it works out whether the number you've passed it is a prime is invisible to you. But because you've tested it and works, it means that when you use it in your code, it's really readable and it's really clear what's going on. That's what we call good practice. That's creating code that you can literally read back to yourself. So it's a lot clearer what's going on. Obviously, there's a lot more involved here, but this kind of moves us in a different direction. So what this week tries to encourage you to do is to use the static class as an example of wrapper functions, and also to see how you can do the same thing properly with objects or differently with objects. Where things get really, really interesting is when we come to week 5. Week 5 is probably the critical one, in the sense that what we're trying to do inside this is that we are trying to put our data inside an object and hide it from easy access and use from a client, etc. There's a lot more involved in it. But here's the thing. What you'll notice about week 5 is it goes back to week 3. I use the example of the array. I just want to give you the shape of it because I'm hoping that you will be able to go through it. So week 4 are, oh yes, absolutely, much more strictly OOP. Week 5 is really the strict OOP concepts start creeping in. And what you'll notice is that the transition through the use of static, well, if it works for those students, it does. Let's hope it does, and therefore it had a value. If it doesn't and it frustrates, I apologize, but there was an intention, I hope, behind it. With week 5, I'm introducing you to objects and what I call wrapping data in objects, right? In order to do this, and this is the one concept that will require you to go back to week 3 and make sure you're confident with how arrays work. But all of these videos, and the reason I have 4 of them just for that one sheet, wrapping data in an object, is because I break it down. In the first one, I take each element of a week 3 piece of code, what it does, how it works, and how I drag it inside and hide it inside an object. Hopefully you'll copy me in doing it. and then start discussing what the advantages, disadvantages are, why we're doing it, what the point of it is, and so on and so forth. There are some really classic questions and issues students typically have about it, and I try to kind of hint at it in there. The worksheet for 5B is, let me just remind myself what's inside here. It's actually quite a simple concept of creating your own string array. Now you might think to yourself, okay, a string array, what is that? A string array is basically this. Just give you an example. If I'll give you a flavor of what I mean. Let's say that I create my own array, my own object, and I'll call it string array, and inside it, let's say, let's call this strarr. I'm just going to leave that on there. That's going to be unfamiliar to a lot of people and perhaps a little bit confusing to those who are relatively new to it. I am recording this, so I hope that this will just give you a sense of what we're trying to do. This is a custom. What I end up doing is I take a bit of data, and what we're going to focus on are doing this with arrays inside classes. We dump an array inside a class. You can't access it because what we're going to do is we prefix it with the word private. So that piece of data is now invisible to the rest of the world. And we develop a bunch of what we call methods. They're basically functions. They look and behave like functions, but we call them methods. And those methods create an interface to this data. And this is a critically powerful element of controlling and managing and understanding why we even have objects. And here's a very simple example. I suspect at least a handful of you play multiplayer online games. And you might ask yourself, what has a course like this got to do with the complexity and sophistication of that type of multiplayer game? Well, the sophistication is to do with the fact that each of those bots that are created are generated from objects. And those objects have a state. So you can have, your weapon status. You can have a bot who's got lower down on certain values and scales because he's been injured and so on. Each object that runs around that landscape and game that you play has a state. That state is essentially data hidden inside the object. Now, those concepts do scale up massively. And this is why we have object-oriented programming and why games, mobile phones, all these kinds of technologies have driven the upscaling and the complexity of it. But here's the thing. If you had to write the code every time you wanted to create a new character or something in a complex game, you wouldn't be able to do it. Procedural programming, the kind of static, what Charlotte describes as Pythonify, actually more strictly would be procedural programming practices, which go back to C. So Unity uses C#, and Unity uses objects. It uses a lot of drag and drop. And when you drag and drop with Unity, I have a fantastic final year project someone's doing in Unity, incidentally, in VR. So if VR does interest you, that's a really, really good thing to do. Yeah, so it uses C# in Unity, and there's things you drag and drop to make up your landscape are basically objects. Yeah, I think actually Unity is free to students. And if you've got a Oculus headset, there is nothing stopping you from playing around with virtual reality. They would, Billy, they would still be good because there's nothing, the only thing that's different in my approach is that I'm trying to lead a path through a series of transitions, right? So the static stuff is kind of procedural programming and it takes you through. Yeah, no, that's fine. Charlotte, that's absolutely fine. I just need to correct your understanding a bit. It's not that it circumvents using inbuilt system. It's a standard practice to build wrapper functions. If I were to tell you in my professional career, when you look at a standard textbook for object-oriented programming, and Billy, this is a comment on your A-level textbooks, A-level, when we teach object-oriented programming, we teach it from the point of view of something called inheritance, polymorphism, and concepts like that. But actually in practice, the most useful concept is something called composition and wrapper functions. In practice, that's what 90% of people who code do. And they work with APIs, and you find, and they're the concepts that I'm emphasizing more. So no, absolutely no worry about it, Charlotte. If I couldn't deal with honest concepts and comments, you must feel comfortable to make comments and ask questions and challenge. Absolutely. Okay, so the idea is, let's just go back to the basic shape of what I'm trying to do with you. So week 5 is a crucial week. I've really broken it down into stages, taken time over it, and hopefully it's clear. Next week's lecture, we'll pick our way through it as well. Week 6 has no new material. What it does have is I give you, and I'll click on it just to show you, and I'll explain why I'm doing this as well. I give you some client code. So there's a public static main, but it uses an object. It uses the class called grade manager, and you have to reverse engineer that class. The video associated with it gets you started, that video there under 6A. So these worksheets, right, will give you code that you'll download, you'll open up, and you'll get the client code, but you won't get the server code. So you have to reverse engineer and say, how do I build? That's what the client's asking. What should sit behind it? Now, why am I doing that? And why am I not introducing more concepts? It's because I'm trying to raise your analytical skills as well. You might think, you know, we're overdoing it now. I don't know what analytical means. Please give me a break. But what I'm trying to get at is, no, you don't. Here, that would be a different type of reverse engineering, Nicola. Yeah, absolutely. And having done that in the past and been involved where we've had no access to the original code and we only had the executables, it's quite a skill to be able to do that. Now, this is a different type of reverse engineering. This is, I give you the client with all the calls, the function calls. You have to build the class that serves that client. Right? When we get to week 6, I'll explain it. It's upside down. It's reversed. Why? Because, again, it's very easy to teach you in a standard textbook way. But what I'm trying to really, UP950787, the answer is yes. It's very easy to teach you in a standard way. But this is what I've noticed. When we get to second year and students arrive in the second year, they can't scale up. They can't apply the skill set that really we should have helped you develop. So this, the aim of this is to try to get your brains working. It's not a ton of code, but it's kind of a devious way to force you to think about what you're doing and getting you to really get your head inside what's going on here. Throughout these 3 weeks, you won't be writing a ton of code, the idea is, but you'll be writing code that helps you get a grasp of what we're trying to get through practice and playing with it. So that's how 4, 5, and 6. Now, let me just explain the overall shape of it. Immediately after week 6, you have a consolidation week, but you also have Easter. So you have 3 weeks off. During that 3 week, I will give you the material for part 3. Part 3's material, which is ready in, if you look at the date, we're looking at 19th of April. So it's a big gap. We introduce composition, and we have two weeks of composition and a very last week on inheritance. Now, these 3 are directly related to your coursework. In fact, the example I use, the example I use, you can adapt to help you build it. You'll get your coursework sometime in April. You won't get it anywhere sooner for a very good reason, I'd like to think. So the point is that composition is quite a tricky idea. What composition does is it takes this idea, right? So if you look at this bit of code, once you get your head around what's going on here, and this may be a good test for you, as you may want to just bounce back to this video and say, do I understand what Nad's doing here and how I would do stuff with it, and what he's going to go on about get setters, constructors, etc., etc. After next week and after week 5, I would hope so. Similar to last year. Jacob, don't tell me they've given you last year. Someone's given you last year's. Yes, it is similar to last year's. Yeah, absolutely. I might have to change it much more radically now that you've just said that, Jacob. Okay, so yeah, anyone who missed their worksheet this week, we can, in the following week, allow you to do it. Because if you think the worksheet 3E is essentially a variation on worksheet 2G, they're very similar to each other. They're practicing loops and conditions to make and stop and start loops and conditions within a loop. And that set of concepts are quite critical with what we need, you know, as a kind of conceptual skill. You see here, right? This is a built-in data type, a string. So I could do this with integers and I'd have an integer array, right? I wouldn't call it str, I'd do that, right? And I wouldn't call my class string array, I'd call it this, right? Yeah, that's fine. Yeah, you can bring your second worksheets, folks, for those who are asking. But what we do with composition is we do something really clever. We take one class we've built ourselves, right? So this is really jumping forward. So let's just say that I have a class called student. And in this class, I have all the data. Remember how this is going to tell you, hopefully hint you how important week 5 is. I have a whole bunch of data related to the student. I might have their name. I might have an array of their grades, right? So I could have, let's say I had this. I'm just feel the concept to it. Yes, this is going into week 7 and I haven't released that material, but I want to connect it up, okay, in your mind to see how the concepts link together and what I'm trying to get at here. So I might have, an array of grades for a student and all kinds of related information for a particular student. This is in fact creating an object, student object. I have my methods which let you access it, analyze it, populate it, and update it and all the rest of it. But that's just one student. So what we can do, right, now this is where your minds might flip out. If you can just hang on for a second, watch this. Let's say that I created another class and I called it, let's take a degree, comp science, right? So let's say that we managed all the comp science students, right? And we wanted to manage all of them in one class. I can create, with that other class I've created, an array of students. Right? I'm not sure how much of that, some of you that might make perfect sense to, those who are new to it might go, bang, that made absolutely no sense. This is the issue about scaling up and why object-oriented code is so spectacular. I can manage the data for an individual student by creating an object called student, right? This is week 7. Right, and in there I have an array of all the grades that student has, and this is typically how these systems are built, right? This is obviously quite simplistic because there's a lot more complex data involved, but I want to manage all my students, right? Not just one. And what I can do is, if I take my comp science students, I can treat that class I've built called student and make an array of students from it. Yeah, you have, Robert, that's absolutely right. So inside that array, you have an array of grades. So each student, and what we have, that relationship between a particular reception. That's a good way of putting it, actually. You can have these really complex pieces of data, but what if you learn to do object-based coding properly, right? When you actually code it, what you'll realize is that the student methods will access and manage all the data related to that. So even if I use it over here, I don't have to build functions in here or methods in here to get the grades out. The grades will be inside the student object. It will tell me all that stuff. Now that's a little bit running forward and jumping, but your coursework essentially uses that link. Your coursework will have a number of different classes you'll build, right? And some of them will have array data. I might not actually have that in it this time. Then you'll have something like a comp science students. The scenario is different. And then you'll have an array of your own objects. Okay, that's after Easter. Now, the reason I'm mentioning it is that is why I've kept it all out of sight. So you work your way through weeks 5. Week 4 is introductory and transitional, right? It will get you to the beginning of an object and some theoretical concepts that are quite important just to hear and understand. Week 5 is where the data comes in, and I'm sticking to arrays, right? So in here, we're talking about an integer array, a nice simple example. You've got to build your confidence with how it works, how it all builds, how you interact with it. In this week 6, you get the chance of looking at an integer array. No, yeah, it's a double array actually, because it's grade manager, and you build the class behind it. So you look at the relationship both upside and forward and all different angles and perspectives to build your strength. You'll have Easter to build this. I'm going to supply you with code with this one. And Alex Bennett and I, when we wrote these as tests last year, incidentally. That's why there's so many of them. They were written as tests, and that we supplied the student with a code. They had to download it. They had half an hour to code these problems. You have much more time. And what I'm hoping with the more time that you have, you'll be able to get your head round and work it. So the idea is that you build all of this material, you play with it, you practice it. It's a repetition, it's a variation, but it's basically you writing code, getting your head inside it. So when I bring composition into the mix after Easter, and I'll probably release that material before to give some of you and anyone who's interested a chance to access it, and also the further composition examples, it will make sense. It won't be so confusing. Because as someone said, arrayception, Evan's concept is actually quite a good one. It can, and as Robert said, it can slightly frazzle your brain because you've got objects inside objects and objects managing objects. In the second year, if you're a comp science student, we build, listen to this idea, we build arrays from the ground upwards. So an array is basically an indexed series of similar values, right? But in your second year, because you're learning data structures and algorithms, in the programming part, I get you to build your own array from objects managed and linked to other objects. So I've talked to the colleague I work with is a professional software engineer, and he's the so he's a PhD student here as well, and we work on the material together. So composition could be used to make a set of objects, could be used for machine learning, deep learning. Absolutely. What you'll find is that my overall strategy links very much to machine learning, artificial intelligence, right? Think about smart homes. That's a hint of the kind of problem you'll get for your coursework, right? How do you manage a smart home? With a smart home, each plug can be an object which can have its state, right? But that object isn't a string, isn't an int, isn't a double, it's a combination of them, right? And that combination is a class, an object you build yourself. You then create an array of them, and then you manage it. I've just actually told you what your coursework variation is, but I suspect that that might go in one ear and come out the other. Jacob, I don't know. Jacob, do you have access to last year's? Because I'm going to have to alter it a little bit in order to work on it. Yeah, not now you said it, exactly. Right, okay, it is being recorded, absolutely. Look, my point here, and you don't, okay. My point here is that for me, the real challenge is to make this interesting and engaging, and you learn stuff. So when you hit the second year, you don't suddenly, your brain doesn't just stop, because getting you through a first year course and you've kind of been able to code the exercises and stuff doesn't, I don't know who called a lie there. It doesn't just run out, you don't run out of steam. So I'm looking at my second years and thinking where the gap is and what I did with them in the first year. And we're looking at this kind of idea of quality code, readable code, understanding what we call programming paradigms, right? Procedural versus object, because comp science students will learn functional programming as well, which is another approach entirely. And I said to Matthew, who teaches the functional, that I've grabbed some of his concepts and dragged them into the first year, because the more your brains are in operation and you understand how these things fit together, think of it like a really complex 5-dimensional puzzle, writing code. The more different perspectives you can approach the problem from, the more likely the whole thing will make sense to you. So that's why you've got this bizarre, seemingly bizarre thing of reverse engineering a class. In week 5, it's reasonably straightforward. So you've got a kind of a map here based on trying to get a similar pattern of concepts repeated, deepened, connected in different ways, echoed here, looked at that, but you know, so the more you code and work through the material, the idea is that your brain starts saying, okay, it's what an object is, that's how it works, that's what I do in order to use it. To use it, actually relatively straightforward, huge overhead in terms of building them initially, but if I'm patient and I build them, that's fine. Now, the other comment that we often get for students who've had experience with programming is that, you know, why do you, Nad, make us use an array, not an array list? Okay, let me just make a couple of remarks. Why are we using arrays? Arrays are quite hideously clumsy, right? You've all used Python lists, right? And Java has lots of inbuilt data types, and one of them is a really popular one called array lists, right? It's too easy for array lists. We must suffer, right? Robert stumbled into array lists. Basically, to learn how to be good at, to benefit from being at university, let me put it like this, right? Some of you could walk out tomorrow and code a solution to a problem in a project. I'm absolutely sure of it. And I've seen it every year. We have some very talented and skilled people. University should be a place where what we do is like you want to become a doctor. And the last thing you want to simply do is just give you a bunch of operations to carry out, right? And just get on with it. You grab the tools, you get on and do it, trial and error, whatever, right? That's not the point. The point of teaching you anatomy for a doctor is the same point, is the same point of making you go under the hood, lifting the hood of the code, and you build objects at a level that helps you see what the inner workings of this stuff are because you're building it. So then later on, as you go into your professional careers and you move into mobile development and you do all kinds of more interesting stuff, you have a much firmer grasp of how everything fits together. I don't think open heart is a time for trial and error. I think you're absolutely right. The analogy is awful. The moment I said it, I thought that was a dreadful analogy. Okay, so that's why I'm not trying to, and I say that, you know, I think that's a fair point, Robert. I mean, in jest, leaving jest aside, this is more difficult than an array list. If I gave you an array list, you'd find a lot of this stuff really easy to just do. It would do it. You could just add stuff to an array list. You could sort it. You can do all that. You don't have to write the code to do it. But you can do that without coming to a university degree. You can do that and be able to pull together. That only makes you a software developer, right? If you think of the levels, a software developer can pull together apps and applications. And that's where it leaves you. By going underground, going under the hood, the idea is that you suffer a bit of pain. Fair enough, Robert. I think that's a fair comment. There's a little bit of pain because you've got to get your brain into motion and think, yeah, how's this stuff fitting together? What's the point of it? Why does it connect? Why do I have to do this? Please ask those questions. You know, that's absolutely fundamental to making you good as students and both good at programmers. For the cybersecurity students here, you won't have to be writing tons of applications. Your use of code is very different. So you must ask, what's the point of it? Why does it work? Me taking you under the hood and getting you to write code under the hood will make you a stronger cybersecurity student because you'll realize what kind of things are built which help systems behave the way they do and why they do behave the way they do and the rest of it. So going under the hood, which is a real aim for me, is to make it a real proper learning experience and a benefit to you, even though it might be painful. Right, okay. Yeah, absolutely. You know, I mean, in fairness to it, there are so many different levels present in the first year cohort, really competent, really experienced. People have done A-level computer science, for example, who programmed in there. That's given you all different levels to operate at. And so in trying to find a threshold and trying to give you something that I'm not sure you would have got before, I approach programming in this slightly different way because I used to teach in a college and used to be head of a department in a college and taught in A-level both in mathematics and computer science and various other different degrees as well there. And I was really struck by if you give students the skills to think this stuff, they'll solve it and they'll get stronger and stronger and stronger. And that's my aim. So this is the crucial distinction. If I were to give you one thought to take away, the difference between the concept, what it is you're doing, like the is prime stuff, versus how you're doing it, right? What you try to do, another way of thinking about objects is that you hide the mechanisms away. You know, think of it like this. Here's a good analogy. You go and work in a large organization. Who works in it? Has anyone worked in a really large organization and done any work experience or got a job in them? They're huge. They have tons of different departments. Anyone? No, I think you've either. Okay, all right. That's a good question, Adriano. Anything where you have more than, I don't know, 10 or 15 departments. So for example, I worked in for a job many years ago while I was studying. I worked in a thing that did the credit card debt, not debt, credit card losing. There's a company down in local to here, forget the name of it. Anyway, if you wanted a job done, you weren't expected to do it all yourself. I mean, this is the basic logic of large businesses, right? And corporations. It's exactly the same logic as large software, ironically. And that's this. I want someone to do a job. I give the data to that department. They do that job. Once they've done it, they give me some message back that they've done it. And that job is done, hopefully properly. I don't have to stand there and say, show me how you're doing it, because I don't trust you. I have to rely on the fact that department knows how to do its job. That's what object-oriented coding is like. You build objects like departments. They do a job, a whole bunch of complex jobs related to a piece of data. You don't worry about how they do it. So the mechanism is not your concern when you're building a program. The concept of what they're up to is, what are they going to do? I'm going to give this department an invoice. They're going to file it. They're going to process it, etc. I don't say how you process it. You never do that in real life. And that's exactly the same analogy we use for objects. Remember, corporations are huge. I mean, Amazon is massive. And that way of thinking about Amazon, about how it splits its functionality across different departments and how it works, is interestingly very closely linked to how software systems are massive as well. Perhaps you can, I don't know, can anyone think of a really massive software system that we can think of that works? Visa, yeah, Visa systems, that's good. PayPal's a really good example. You'll find with these systems that this is all using objects with data, carefully managed. Amazon Web Services. We had a student who was placed with Amazon Web Services, incidentally. If anyone's interested, I wonder if he's still here. I could try to get his details to you. The NHS is a very good example as well. Absolutely. So I hope you appreciate, even though at this stage some of you may be a little bit skeptical, and I think that's fair enough, and remain skeptical, I have no problem. My purpose is not to indoctrinate you, but it's to try to encourage you to think and to challenge and ask questions. You worked for a Santander. Santander is a very good example. Babcock's a very good example as well. I don't know who Yokogawa or Marex are, but I suspect, yeah, Tesco's is a very good example, aren't they? I mean, they're huge as well. So all of them partition up their jobs into these sort of departments. A department is, in my opinion, the nearest analogy to an object. So you can see that, just to go back to the very starting point, that static stuff that we had doesn't scale up. And I explain it more clearly through the videos of why that stuff is useful, but very limited. It's useful for things like, in an introductory course, having methods, very simple methods to not have to write system out print line. You wrap that functionality, make that interaction very simple, so your code is more transparent and lit into the concept, and stuff like that. So keep whatever views you have with how you're approaching it, but let's make this a way to encourage you to think differently about it. And really, truthfully, there is no, it's not basically if you don't agree with me. And I just want to make this absolutely clear. If you don't agree with me, then you're doing it wrong. That's absolutely wrong. What's right is that what my aim here as a teacher and an educator is to give you one approach to grasping how these concepts fit together. And having worked in the industry and worked as a software engineer, I can tell you for a fact that they're all based on real things. And my colleague who's still a consultant out and he does tons of software, we spend a lot of time discussing how to approach teaching it. And he would sit here and he would agree with what I'm saying to you, that what I've got, the best I can hope for is that I stimulate your thinking, you get your head inside it, you enjoy it, and you feel confident that this is not going to be an obscure and painful piece of coursework. And painful sort of experience for you. Let's hope that I can make it more enjoyable. Anyway, preachy mode off. I just say that because I don't want anyone to feel any kind of anxiety about asking me questions and saying, Nad, you're completely wrong. I have had students say that, I disagree with you, Nad. I say, please do disagree. Disagreement's really healthy. And then it challenges me to think, how am I explaining it? Am I being too kind of dogmatic, or am I really doing it in a way that encourages you to think about what you're doing and how I'm trying to do it? Okay, so that's, I suppose, the best I can do here. I hope that the plan, the roadmap then for the remaining 3 weeks before, thank you, Kobe. I hope the roadmap is relatively clear. I redid this material this early part of the week, did basically a binge thing. So my brain is slightly frazzled. If there are typos you spot along the way, I'm usually quite diligent, but sometimes the odd one will slip through in an obscure statement in a lecture sheet. Please feel free to ping me an email and say that is really obscure. I went through the sheets about 4 times to make sure I hadn't really got very abstract and obscure. Which is probably my shortcoming because I like abstract stuff. Okay, so folks, some of you, all of you, most of you, I don't know, have remained here and remained fairly patient. It is recorded. Tomorrow is much more fun. It will be the array. So tomorrow's material will come from the lecture slides. So go back through them and scan your way through them or make them available to you, because all the questions are just lifted straight out or in variation of the actual lecture material. Okay, so if you miss one of the learning catalytics, Matthew doesn't average them all. He only selects your best. I don't know how many out of the total amount we're doing. We had to have an agreement of how many we were doing, but he takes only a percentage of your best ones. So if you miss the odd one or you have a bad week, it could be 10. It could be, but actually what I think Matthew and I are the top 10. Matthew might make it, he might reduce that number a bit. He might make it the top 7, just to make it a little bit more generous towards you. Top 7, top 8. We'll have to make a decision and a judgment on your experience of it, because look, the truth is we can educate you and teach you, but we don't want to make it such a relentlessly painful experience that you're just shattered and exhausted, but you get to the end of the year and you've done all of this stuff. We need to make sure we keep the balance. Overall, it's 10%, I think. Yeah, but don't pin me on that, whether it's 10 or whatever. If it's 10 across 2 terms, then you know, maybe Matthew will take 5 from each of us. I don't know. I'm roughly trying to aim for 10 questions a week, and I'm aiming to keep them as simple as possible. So all you really need to do to prepare is just scan, make sure you're comfortable with the lecture material. And as I say, let's keep that bingo stuff going, because that's actually quite a nice way of ending the week and giving you something quite light. Any other questions, folks, about it? I hope my thinking process was a little bit more visible to you. Like hiding, what is that? Hiding during inheritance lessons. We will be doing some inheritance, but the inheritance will be, I'm not a huge fan of inheritance. Can I just be really frank? In my professional career, I worked with an IBMer who was 20 years trained, and he hated it as well. So he kind of biased my opinion about it. So I'm doing it because you need to understand it. There's an element in the coursework that will allow you to use it. So there'll be enough for you to be able to work your way through that. But what you'll find is composition is the concept that you'll hear the most from me, because that in my professional career was the most important thing. That links to APIs, that links to, hang on a sec, Lucas, I'll just answer that. That links to APIs, that links to all the stuff we've been doing with wrapper functions, mobile development, tons and tons of stuff. Composition and wrapping functions, very prevalent practices, right? Okay, can I just end on one last thing, folks, just before you all disappear? If you want a summer placement, get in touch with Emma from the department. I can't remember the name of the department, folks. And you apply for your placements when you're in the second year, but you can start now if you want to. Okay, folks, thank you for your patience, and I hope it was clear and not too much nonsense, folks. Thank you all. Cheers.